What?
Hello everyone. I'm Sumukh from Pencil. I'm the co-founder and CTO of Pencil. So what does Pencil do? What we have claimed here is AI for creativity. So what we are trying, or what we are really interested in, is can machine-generated content be creative and be accepted in the real world? We're starting out in the domain of advertising because it's really a lot of data, a lot of continuous stream of data available, and we're trying to see if we can make it possible for ads to be interesting while not annoying. We're introducing the world's first generative creative platform for performance advertisers. So what do? So we work with algorithms to generate advertising language and visuals that are predicted to be creative, effective, and on-brand. These we believe are the principles and should be the fundamentals of any advertising, not like the ads that we see online, which all of us have ad blockers on to kind of stop it. So the fundamental question here, how do you predict language for ads to be creative, effective, and on-brand? So today I'm going to talk about the language part. Similar concepts apply to the visual, but I'm just taking the example of language here. So how do you predict language is creative, effective, and on-brand? These are three very different kind of challenges, three very different kind of problems, and we're trying to solve all of these. So what we've tried to do is, if we believe that if language has to be creative, it comes from the emotional connect in the language. If it has to be effective, then you need to have the ability to predict if a certain piece of language is going to perform well for advertisers. And third thing is definitely every brand is concerned about whether the ads it generates, or even if a copywriter writes, is whether it is in the style of the brand. Does it represent the brand? So today I'm not going to talk about performance prediction or on-brand score. Those are relatively easier and less interesting. So let's talk about emotional reaction, right? How do you predict what kind of emotional reaction a piece of language will evoke in someone who's reading that piece of language? So I'm trying to do that. So where is the data for this? Nobody has collected data for this ever in the world, or even if they have collected, nobody's going to give it away. So we are a startup, we don't have data. So how did we reach this data? So what we did is, we went and collected data from Facebook reactions. All of you use Facebook, all of you see news posts and other things. You're reacting continuously to saying that whether you like it, you heart it, you love it, you're angry, you're sad. So we've effectively piggybacked on that system. So we have collected a lot of data, public posts, nothing private, public posts about how people have reacted given the visual and the copy associated with it. Copy, I mean text. This is the kind of roughly the data that you get. A lot of garbage, but still a lot of insight that can be drawn from this. So what we did is essentially took the posts from a lot of news and blog accounts which are publicly available, harvested the likes, love, fun, wow, sad, angry, comments, shares to get this. I'll leave it as an open challenge for anybody to go and easily find this data. It's not that hard. Spend 10 minutes on Google and you can get your hands on this data. Now, the next question is, what do we do with it? How do you can see here the numbers are extremely random, extremely sparse. Like likes go from all the way from 1,800 to 25,000. So, and all the other counts are also extremely diverse in its range. Now, the fundamental question is, without knowing how many people actually saw this post, it's very hard to normalize this information. Like, it could go from 100 to 1 million, and without knowing actually a fact of how many people actually received this post and could see it, you can't normalize this. And that data is only with Facebook, and obviously they're not going to share it with us. So that's the question that I'm trying to answer first here. That there are two ways we could normalize this, right? You could go take the maximum in any given column, normalize by that, and try to do it. But some features are unbound. So today we may see that our training data has something like, if you see the likes column has something like up to 33,000. So you say, okay, let me normalize it by 50,000. Fine, we'll get something between 0 and 1. But tomorrow you may get a post which is 60,000 likes. So what are we supposed to do with it? So it's extremely unbound. So what we did was we did a second kind of normalization in the sense that why do we care how many total number of likes, shares, or any of these emotional reactions are there? What we really care about is, given a piece of text, how much proportion of the likes, shares, comments, and the love, haha, and all those things, what is the proportion of them individually for that? So we believe that if something evokes more anger, it should have more anger as a percentage across the row. So you take any one given row, sum up the horizontally, and then divide it. So what we're trying to achieve is, like, let's say, what is the proportion of people's reactions who think this is funny versus who thinks this is angry. Then we just thresholded it, saying that, okay, if anything receives more than 0.5, let's call it a 1, and anything which is less than 0.5, let's call it a 0. So saying that anything which more than half the people think is funny, okay, let's think it's funny. And if more than half the people say it's angry, fine, let's go with it. So we end up with, for every row, we're only looking at emotional reactions. I'm not counting the likes and shares and comment counts. I'm only looking at the those which have received the love, the funny, the wow, the sadness, and anger scores. So so you end up with the labels being something like this. So your data set essentially after cleaning is like a piece of text and some numbers like this. What do we do with it next? So we have three choices. We could go with, one is, let's try to take, this input is common, but we have multiple different classes to predict. So we could go with three kinds of models. One is individual models, which for each kind of the reaction. So you could have something which just predicts whether a piece of text is binary classifier, which says whether it is funny or not, angry or not, or sad or not. The other one is you could go with a multi-class model saying that, hey, a piece of text can only be one thing at a time. Let's try to say whichever is maximum in that in terms of proportions. Before we have thresholded, take the maximum and associate a label saying a piece of text is only funny or angry or something like that. But that's too naive in my opinion, because a piece of text which may be angry to some people may evoke a funny reaction in some others, or sad reaction in some others. So it's a very fluid thing, right? It's like text itself is extremely fluid. Emotions are further fluid from that. So it's very hard to say that, okay, let me just associate one particular label to each given piece of text. At the same time, individual models don't work so well because you're not introducing cross information among that. So like something which is funny is also expected to be quite wow or surprising as well. So there is a little bit of play here where labels itself have some kind of interdependence. It's not completely, or something which is sad is also expected to evoke anger response. So there is an interdependence. So just throwing out all that information is kind of seems like a waste. So what we went with is, let's try to build a multi-class, multi-label model. So in the sense that, okay, you have 5 classes to predict, but we said that for any given piece of text, it could evoke more than one kind of response. This is really hard. So because once you decide that, okay, fine, this is what we want to do, the next biggest concern is, what is your metric? How do you say if your model is even working fine or not? Like for binary things, you can say, okay, fine, number of times I see my model is saying yes versus the ground truth. Fine, that's okay. Multi-class, still okay. You can say number of times a particular class is being agreed upon with the ground truth is okay. But when you come to multi-class, multi-label, you'll see that actually most metrics that you learn in theory fail to work. It's really hard to predict whether this thing works. So it requires extremely deep analysis into going, once you've built the model, into seeing that is every class working fine. And also you need to consider, if something is thought as funny in the ground truth, and if the model says it's wow, that's not too bad. It's not too bad. So even penalization is not constant. You would say that it's really bad if your model thinks it's angry versus what is the ground truth which says it's funny. So there is also the impact of whether these classes have tolerance of misclassification. So there are multiple considerations over here. I'm not going to go very deep into how do you do this error analysis and what are the metrics you should use. That's the fun part of being a data scientist. But after this, I want to talk a little bit about the results. I don't know if, can I open a link? Oh shit, you don't have access. Sorry. Okay, so yeah, I could. So this is the kind of data set, on the validation side. So what we do is we predict the likelihood of every reaction for a given sentence, and then we see against 0 to 1 score, versus we have something called engagement rate. Ignore the engagement rate, the Y column. That's not something that is visible for you right now, but more think of it in terms of the horizontal scale. What we are looking at is the various different reaction scores, and if you hover on any one of them, it shows you that sentence and what is the predicted score. So you can see that it's working fairly well. So if you receive a sentence like last seat missed moment, oh yeah, that will say like, oh shit, I missed it. So it is predicting. The model is similar. So we were surprised when we saw this, because as in my experience as a data scientist, I expected this model to behave extremely poorly, but so it works surprisingly well. So in terms of the model details itself, it's a very straightforward. We used a fully connected network, nothing very advanced. One of the important things that we did in this step is the importance of that you need to know that your model tends to overfit for these kind of complex tasks. So you have to be very careful about certain principles, like you need to have dropout and other things which help the model generalize better. We trained this model about a year back, still has a lot of validity for our day-to-day use case in our system. We trained it only on 75,000 samples. That's the other thing in reality, that you actually have very low data sets to deal with. So we trained it on 75,000, still works fantastic. We have now collected about 3 million samples for this. And yeah, it's open to anybody who wants to come and see what happens and if they train next version of this model. Yeah, so we're looking constantly for interns who are eager to come and work with us. We've had some fantastic experiences working with interns from NUS itself in the past. Any questions? Cool, thank you. I'll try to keep it open. I'll make the link open so that anybody can access it.
Okay, so Sumukh has kindly shared his slides with us, and he's let us take this. So you're welcome to talk with him. He's going to stay here for a couple minutes for those of you who might be shopping for internships. It's always good to know some of the people in the industry that you can cut your machine learning projects on. So that's all for today. We tried to keep it light. You will have a tutorial next week on what we learned on regularization and validation, but that will be very light. We promise to keep it light during midterms week, okay? So we'll see you soon, okay? So please come and interact with our guest speaker. I'm sorry Vicente had to run off, but I thank you all for staying back. Okay, let's have a hand for Sumukh at Pencil.AI. All right, okay, see you guys next week, or come and interact with our speaker. Thank you. Okay, yeah. Okay, you wrote down your meeting plan? Yeah. Okay, send us the yeah, you wrote it down on your paper, right? So that's a double copy. Yeah, if you don't answer them for MCQ, for MRQ, if you didn't mark something that you were not supposed to mark, then you would mark it.
I was thinking of randomly shading for the MCQ.
You can do that, yeah.
But I forgot to shade it, so...
Well, there's nothing we can do about that, I'm sorry, yeah. So that's why we put on the slide at the beginning, make sure you at least try something for everything. Okay, yeah, thank you.
got 173.
Okay,
And,
173.
yeah.
Okay. Maybe we had one student drop and the other students over there, so I think we're all set. Yeah. Thanks, gentlemen. I don't know how we would do it without you. It's too much running around. Yeah. Okay. So, yeah, thanks a lot. Yeah. So we're all good.